Mathematics is used to model, explain, and solve real-life situations. The field of applied mathematics is all focused on this. In nearly every situation, we observe that one quantity depends on another. And one way to represent that in our mathematics is to use what we call a function. A function is a rule that takes numbers as inputs and assigns to each a definite output number. The set of all input numbers is called the domain of the function, and the set of all output numbers is called the range of the function. We can also define a function to be a correspondence between the domain and the range, such that each member of the domain corresponds to exactly one member of the range. If we have two items or two quantities that are related but not in this functional way, where one input is assigned to one output, we call this pairing a relation. A relation is a correspondence between a domain and a range, such that each member of the domain corresponds to at least one member of the range. So a relation, the input could have more than one output. The function is really just a special type of relation, very much like a square is a special type of rectangle. A function describes how the value of one quantity depends on another. We can represent a function by a table of numbers, words, a graph, or a formula, and in this lesson we're going to explore all of those. In everyday language, a function expresses dependence. One quantity, the outcome, depends on the value of another, which we call the input. In a way, we can think about a function as a machine. Here we have some donuts. And let's say that our input, which we will call x, our input is the cooked yet unglazed donut. The donut travels along in the machine all the way around through the glazing where it is covered in sugar, and then it comes out as glazed final product donuts. So our machine F will take an input value, an unglazed donut, and turn it into its output value, a glazed donut. I will talk about that notation F of X very soon. Here's a visual for us. If every value of the first quantity has exactly one value of the second quantity, then the second quantity is a function of the first. So a function example, we have one input value that's headed to one output value. This is a function. This is true for every single input value. They all get mapped to one output value. But in a relation that's not a function, one input value could go to two different output values. And that's really the biggest difference between them. Let's take a look at two examples of the same data, but we're going to look at it in two different ways. Here we have some baseball teams. In the first example, our domain consists of the team names, and our range consists of their location. Where are they located? So in the first example, notice that we have the A's mapped to Oakland because the A's are in Oakland. The Giants are in San Francisco. The Cubs and the White Sox are both located in Chicago. And then the Angels, even though they may be the LA Angels, they are located in Anaheim. So we have a relationship between teams and location. And the question we have to ask ourselves is, does each team get only one location? This is a true statement. Each team gets exactly one location. One team cannot be based in two different cities at the same time. So this is a function. In our second example, let's flip it around. Let's let the domain be the location and the range be the teams. So now we have Oakland going to the A's again. San Francisco goes to the Giants. Chicago gets both Cubs and White Sox. And Anaheim goes to the Angels. And now we ask ourselves the same question, but this time our input and our output have changed. Does each location get exactly one team? And here we have Chicago going to two different teams. And since the input goes to two different output values, this second example is not a function. We have 4 examples here. Determine if each of these is an example of a function. We have our domain, the correspondence, this is our function, how they're related, and then our range. And we have to determine if it's a function or not. What I'd like for you to do is take this moment right now and try it on your own. Pause, take a look at each of these, resume, and I'll work through them. Let's pause and do the first one, resume, and we'll work through the first one. And that way it helps you adjust if you have mistakes or misunderstanding. We can get those corrected right away. But it also gives you a chance, when we pause and try it on our own, it gives you a chance to see if you understand the definitions and the previous examples to be able to apply to these examples. Okay, hopefully you've got an answer for number 1. Do we have a function? Let's find out. Our domain are the student names. The correspondence is by W number, so each student has a W number. The range is all the W numbers that we could possibly have. Do we have any situation where a student would go to 2 different W numbers? Would one student end up with 2 W numbers? Well, in an ideal world, no. Every student has only one W number. Sometimes a computer glitch happens, but we're going to assume that in a perfect world, we don't have the possibility of 2 W numbers for one student. So this would be a function. One student to one W number. Pause and try number 2. Okay, do you have it? Let's talk through this one. W numbers. The overall grade in a class for that W number. So for example, in our class, the W number would get mapped to a letter grade, A, B, C, D, or F, whatever happens at the end of the semester. In this case, does each W number only go to one grade? Do we have a situation where one W number would get 2 different grades? Now we're talking about one single instance of this class, so this section of this class. Maybe there was a previous section that a student took and they got a different grade, and that's why they're taking this one again, which happens. But that's a different class, possibly with a different teacher. So we're focusing only on one class, one semester, one class. In that one semester, one class, can a W number end up with 2 different grades? No. A student only gets 1 grade in a class, so that W number is only going to go to 1 grade. This is another function. In the third example, we switch the domain and the range. Is that a function? So here we have the grades A, B, C, D, and F, and the student W number based on that grade. The grades are going to map to the W numbers. So a grade gets mapped to the W number. Is that a function? Could the B go to another W number? Sure it could. There are only 5 grades, but there are 30 students. So absolutely, these grades could get mapped to more than one W number. This is not a function. One input is going to more than one output. And then how about the last one? we have our postal address, where we live, our address. The correspondence for the postal address and a person's name is the fact that the person lives at that address. Is this a function? Do we have one address mapping to one person? If I have an address mapped to a person, if that person lives with someone else or has kids, then that address is going to get mapped to all of the people in that house. We have one address to more than one person's name. This is not a function. So do notice the difference. We can have W numbers that are different, but those W numbers are going to go to the same grade. That's okay because one input on the domain side goes to only one output on the range side. We don't care how many inputs get mapped to an output. That doesn't matter. B could have the entire class mapped to it and still be a function in number 2.